Now let's move on to volume studies. Traffic volume studies are conducted to collect data on the number of vehicles or pedestrians that pass a point on a highway facility during a specified time period. This time period varies from as little as 15 minutes to as much as a year depending on the anticipated use of the data. So the data that is being collected may be put into subclasses which may include directional movement, occupancy rates, vehicle classification, and pedestrian age. So we have to take note that for traffic volume studies, so this is a collection of data on the number of vehicles that pass on a point on a certain highway facility during a specified time period. And basically, the time period may vary from 15 minutes to a year, which depends on the anticipated use of the data. And for traffic volume studies, are usually conducted when certain volume characteristics are needed, such as number one, average annual daily traffic or the AADT. This is the average of 24-hour count collected every day of the year. AADTs are used in several traffic and transportation analysis. So basically, it's used for estimation of highway user revenues, for the computation of crash rates in terms of number of crashes per 100 million vehicle miles, for establishment of traffic volume trends, for evaluation of the economic feasibility of highway projects, for the development of freeway and major arterial street system, and for the development of improvement and maintenance program. Then the second one is the average daily traffic, the ADT. This is the average of 24-hour counts collected over a number of days greater than one but less than a year. So this ADT, or the average daily traffic, is used for planning of highway activities, for the measurement of current demands, and for the evaluation of existing traffic flow. And the third one, you have here peak hour. You have the peak hour volume. This is PHV, which is the maximum number of vehicles that pass a point on a highway during a period of 60 consecutive minutes. So the data collected on peak hour volume is used for functional classification of highway, for the design of geometric characteristics of the highway, for capacity analysis, for the development of programs related to traffic operations, and for the development of parking regulations. The fourth one is vehicle classification. The records volume with respect to the type of vehicles, for example, passenger cars, two-axle trucks, or three-axle trucks. So this is actually used, the vehicle classification is used for the design of geometric characteristic, for capacity analysis, for adjustment of traffic counts obtained by machines, and for structural design of highway pavements, bridges, and so on. Then the fifth one is vehicle mile of travel. Vehicle mile of travel is a measure of travel along a section of road. It is the product of the traffic volume, which is the average weekday volume, or the ADT, and the length of the roadway in miles to which the volume is applicable. So basically, the data for the VMT is used as a base for locating resources for maintenance and improvement of the highway. Then we move on to methods of conducting volume counts. So for the methods of conducting volume counts, there are two methods actually. It can either be a manual and automatic. So basically, for manual method involves one or more person recording observed vehicle using a counter. With this type of counter, both the turning movements at the intersection and the type of vehicles are being recorded. So for this one, we have here the illustration using a jammer traffic data collector hooked to a computer. So for that one, the main advantage of the manual count are it is labor intensive. The main disadvantage rather. The disadvantage of this, it is labor intensive and can be expensive. It is subject to limitations of human factors, and it cannot be used for long periods of counting. Then for automatic method, automatic counters can be classified into general categories. Those that require the laying of detectors, such as surface or subsurface, and those that do not require the laying of detectors. So for automatic counters that require laying of surface detector, or subsurface detector on the roads, it detects the passing vehicle and transmit the information to a recorder, which is connected to the detector at the side of the road. So we have here a sample, a setup actually, a sensor setup of a surface detector using pneumatic road tubes. Then of course, we have here the Apollo counter classifier, which is particularly suitable for cities and countries. It is capable of obtaining per vehicle or volume data. Then the 3M Canoga C900 series vehicle detectors thus use an inductive loop to identify the presence of individual vehicles and determine speed, length, occupancy, and obtain vehicle counts. So they're designed to use either standard inductive loops or 3M's non-invasive micro loop model 702 probes. So for this one, for the automatic counters, it does not require actually the laying of detectors used one of many technologies, including electronics. So this one is, we have here an illustration for the Apollo. This is actually the device. This is the device for the Apollo traffic counter classifier. Then another one, we have the RTMS. It uses the Doppler or FMCW principles, and both are capable of obtaining volume vehicle counts while obtaining speed data. Then for traffic detector sensor, this is manufactured by an OSI laser scan. It emits two scanning laser beam to create a 3D image of each vehicle that passes through the field of the beams, thereby classifying the vehicle. So we have here the illustration. This is the device for the Canoga vehicle detector for C922 and C924. And this is the Canova microloop sensor. And we have the Canoga 702 non-invasive microloop sensor. These are example of counters that require the laying subsurface detectors. So these are devices that require the laying subsurface detectors. Then we have here the Traffic Eye Universal System. So this is an illustration for the Traffic Eye Universal System that is being installed within the highway. And this one is an example of station locations of a cordon count. So we have here a cordon count on a specific station location. Then we move on to types of volume counts. For the types of volume counts, it is dependent on the anticipated use of data to be collected. So there are different types. So we have here the cordon count. So this is the illustration for the cordon count. When information is required on a vehicle accumulation within an area such as the central business district of a city, particularly during a specific time, a cordon count is undertaken. So the area for which the data required is cordoned off by an imaginary closed loop. The area enclosed with this loop is defined as cordon area. So that's when, if you're going to observe, you have a loop, and that area that is being cordoned is what we call now the cordon area. Then screen line counts. For this one, the study area is divided into large section by running imaginary lines known as screen lines across it. So in some cases, natural and man-made barriers such as rivers or railway tracks are used as a screen line. So traffic counts are then taken at each point where a road crosses the screen line. So for this one, for the collection of data at the screen line station at regular interval facilities, the detection of variation in the traffic volume and traffic flow direction due to changes in the land use pattern of the area. So for the intersection counts, this is being conducted to determine vehicle classification through the movement and turning movements at a certain intersection. So basically, the data being collected are used in determining the phase length and cycle times for signaled intersection in the design of channelization at intersection. So basically, in the general design of improvements to intersection. Then we have pedestrian volume counts. These are made at locations such as subway station, mid-blocks, and crosswalk. So the pedestrian volume counts are taken at these locations when the evaluation of existing or proposed pedestrian facilities is to be undertaken. So such facility may include pedestrian overpasses or underpasses. Then for periodic volume counts, in order to obtain certain traffic volume data such as the AADT, it is very important to obtain data continuously. However, if that is not feasible to collect data in a continuous manner, all the roads, because of the cost involved, to make reasonable estimate of annual traffic volume characteristic on an area basis, different types of periodic counts with duration that ranges from 15 minutes to continuous are being conducted. Then for continuous counts, these counts taken continuously using mechanical or electronic counters. So the station at which continuous counts are taken are known as permanent count stations. And for control counts, these counts are taken at station known as control count station, wherein strategically located so that representative samples of traffic volume can be taken on each type of highway or street in an area-wide traffic counting program. And for the last one, the coverage count, these counts are used to estimate the ADT using expansion factors developed from control counts. So actually, the study area is divided into zones that have a similar traffic characteristics. Now we move on to traffic volume presentation. So basically, the data that was collected from traffic volume counts will be presented actually in several ways, which is dependent on the type of count that was conducted and its primary use of the data. So here are some of the presentation techniques. So we have the traffic flow map, which is this map shows traffic volume on individual route. The volume of traffic on each route is represented by the width of the band, and that is drawn in proportional to the traffic volume it represents. Then we have the intersection summary sheets. These are graphic representation of the volume and direction of all traffic movements through an intersection. The traffic volume can either be ADT or PHV, which is dependent on the use of the data. Then we have the time-based distribution chart. It shows hourly, daily, monthly, or annual variations in traffic volume in an area or on a particular highway. Then, of course, we have the summary table. This table gives a summary of a traffic volume data such as PHV, vehicle classification, and ADT in tabular form. So we have here an illustration for our sample of traffic flow map. So this is one way of presenting our traffic volume counts, the data from our traffic volume counts using a traffic flow map. And this one is through an intersection summary sheet. So this is also a way of presenting our traffic volume counts.